Today we will introduce a relation and a function. Relation and a function are the most important topic in algebra or any other math that you're going to take. These are the two different words having different meaning in math. So the relation shows the relationship between input and output, where the input is the x value and the output is the y value. Then we can write as an ordered pair as x comma y. But the function is a relation which derives one output for each input. Every input will have one and only one output, whereas the relation could have the same input, could have two different outputs. But the function has restriction, which shows every input must have one output. Knowing that, so let's start differentiating between relation and a function. You can display a relation as an ordered pair, or as a table, or a mapping, or a graph, similar to this. So as an ordered pair, you write x value comma y value. So as you can see, -2 has a relationship to 1. -2 also has a relationship to 3. And so on. When you write in a table, you can write as a horizontal way or a vertical way. It doesn't matter how you write it, as long as you're showing the relationship between x and y. So x value, when x value is a -2, y will be 1, similar to here, so and so on. But when we are mapping, we will use an arrow to indicate how do we map -2. We'll map into two different values, which is a 1 and 3. Meaning 2 has a relationship to 1 and 2 has a relationship to 3, and so on. But when we use in a graphical way, as you can see, the graphic has a vertical line, which is the y, and the horizontal line, which is the x. So this location is the origin, which is 0 and 0. On the left will be a positive number, on the top will be positive, whereas on the left and the bottom is a negative number. So as you can see, when x is 3, y is 1. When x is 1, y is 4. And when x is -2, y is 1. Also when x is -2, y is 3. And also when x is 0, because the origin is a 0 and 0, y will be -3. So that's the only 4 different ways that you can display a relationship in math. Knowing that, let's see why is a different function than relationship. A function is a kind of relation, but it follows an extra rule. What will be the rule? It says, similar to a relation, a function is also a set of ordered pairs. However, every x value must be associated to one and only one y value. If one x value has two different outputs, then that is not a function. That relation is not a function. So let's look at the two different, whether this function is a relation, whether relation is a function, or relation is not a function. So let's look where the relation that is not a function. Why so? As you can see, x is -2, and then x -2, and has two different outputs. Because of that, this is not a function, because every input must have one and only one output. As you can see, we cannot reduce -2 implies to 1, and -2 implies to 3, which violate the function rule. So let's look when we have a function. As you can see, all the x values are unique. There is no repeating x value, whereas here was -2 and -2. But here you will see x will be -2, it appears only once. 0, similar to that, 1, 5, 7. And then every input, which is unique, will have one output. But let's add one more. Sometimes you might have -2 associated by -3 and 0 associated by -3. It still is a function. The only thing that we need to know is whether the x repeat or whether one x value has two different outputs. But all the x value of different could have the same input. -2 could be -3. 0 could be -3. And 1 for x could be -3 for y. 5 could be -3 for y, and 7. That will also be a function. The only thing that you will consider is when the x value repeat, does it have two different outputs? Then you will say it's not a function. So knowing the difference between function and relation, let's look for those examples. It says determine whether each relation is a function and explain. As you can see, we only consider for the x value. The x value has -6, -2, 1, and 3. And each input indicate one output. So this will indicate, yes, it's a function. So let's look for 2. Before we even look, we see that when x is 4, has two different outputs. One time the 4, the output is 2. And when the input is 4, the output is 5. This is not a function because one input has two different outputs. Let's see on number 3. Always you have to look for the x value or for the domain. Always x value is the domain, y value is the range. Just look for the domain or the x value. Does it repeat? As you can see, the x is a unique. 4, -1, 0, 1, and 9. And then 4 associate to -5 for y, -1 associate to -10. So this is also a function, yes. What about number 4? We can see x when it's 5, y is -3. Also when x is 5, y will be a 2. That violate the function rule, which indicate every input must have one and only one output. So this is not a function. So that's how you look for when you have a table. When you have a table, you just look for whether the x value has, one x value has a two different output. But what about when we have a graphical, that we don't have any numeric? So how can we tell whether this line or whether this graph or this graph, which one is a function? We know when we have an input and output as a value, we can look for if the x value has a two different output. So now we will learn a new concept that we need to check. We will use something called a vertical line. If the vertical line crosses the graph more than once, it's not a function. So let's test. So this will be my one vertical line. As you can see, I'm only crossing once. If I do another location, I'm only crossing one, which indicates every vertical line will touch the graph one and only one. So this, yes, is a function. So what about when we have this type of graph? So let's do the vertical line. As you can see, if I go through, I'm touching the graph on this location, then I'm going through there, I'm touching another location. This graph has two different, let's say x is 1. If x is 1, y will be 1, and when x is 1, y will be -1. 1 produces two different outputs, so this is not a function. So that's when you have a graphical way of doing it. So now let's look at different concepts. How do we write a function rule from a table? Always you have to analyze how the pattern for the x and the pattern for y. Then you can indicate how do they relate y and x. So as you can see, x increases by 1. It will be 1, 2, 3, and 4. But the y increases by from 9 to 10, 1. 10 to 11, 1 also is 1, which indicate then we have y will be equal. When x value we increase by 8. Let's check. When x is 4, 4 plus 8 will be 12. When x is 2, 2 plus 8 is 10. So that's this table associated to this function. So what about this one that we cannot see the pattern? If you see the x, the pattern increases by 2. But the y increases from 12 to 20 is 8. 20 to 28 will be 8, so it will be 8 increasing it. So how do we see that? Are we using addition, subtraction, multiplication? We could see that when we multiply 4 by 3, we're getting a 12. 4 times 5 will be 20. 4 times 7 will be 28. Which we know that we will multiply 4 every x value. So your y will be equal to 4 times whatever the x value is. So that is the topic that you learned today. So be careful when you're writing a function rule. You must look the table, the x value and the y value, and then you need to figure out how do they relate to each other.